Welcome back to section 1.1, operations on real numbers. Today we're going to talk about rational numbers, operations with rational numbers and with irrational numbers. But what is a rational number? Sometimes it's best to just have examples to explain. A rational number can be written as a ratio or a fraction of two numbers. And if you think about the number 1, it can be written as 10 over 10 or 1 over 1. So it's rational because it can be written as a ratio. 7/9, -36, 1.55, 6.1, repeating. So it goes on and on, 1, 1, 1, 1, 1, 1, 1, 1, 1. It repeats, but and it never ends. But because it's repeating, it's rational. It can be written as a ratio. It can be written as a fraction because the number 0.1 repeating is actually 1/9. And you can check that in the calculator by doing 1 divided by 9. So these are rational numbers. 0 is rational. The square root of 25 is rational because it equals 5. It's a perfect square. So lots of numbers that we work with are rational. On the next page, we'll talk about irrational. Is the sum of two rational numbers always a rational number? Well, our definition of rational means it can be written as a ratio or a fraction. So let's use some algebra. A over B plus plus C over D. We can add these together, and what we want to find is the answer rational. So we need a common denominator. So we're going to have A times D over B times D, so that we just multiplied the first fraction here by D over D, and that's how we got this. Okay, and then we're going to add CB over DB because we multiplied by B over B to this fraction. That equals, on the denominator, you can see that this denominator here and this denominator here are both made up of B and D. So we can just change the order so that it's BD. And on the top, the numerator, we have AD plus CB. So our answer is a fraction, which means it's rational. So yes, and you can even test it with numbers. 1 plus 1 is 2. That's rational because I can still write 2 as a fraction, 2 over 1. 1/2 plus 1/2 equals 1. That's rational. The square root of 25 plus the square root of 25 is 2 square roots of 25. It's still rational. Same thing with products. Products mean we multiply. So we can use fractions again. A over B times C over D. And when we multiply fractions, we just multiply across. A times C is AC, and B times D is BD. Is that still a ratio? Is it still a fraction? Yes, it's still a rational number. And we can test that with actual numbers as well. So if I had 9 times 1/9, these are both rational, I would get 9 over 9, which is rational because it's written as a ratio, or it equals 1. Either way, the answer is yes. The product of two rational numbers is always rational. So just think of rational numbers as numbers that you've been working with ever since you got into math. Let's turn the page and we'll talk about irrational numbers. What are irrational numbers? So an irrational number is like pi. It's equal to 3.14159, and it goes on and on forever. It doesn't stop and it doesn't repeat. There's no pattern. It's not like 3.1414141414. No, it has this random sequence of numbers that go on and on forever after the decimal. The square root of 2 is not a perfect square, and it equals a decimal, equals 1.4142, and some numbers after that. It goes on and on forever. There's no pattern. It's not repeating. That's irrational. And a bunch of the square roots are irrational. Like the square root of 5 is irrational. And you can check what that is in the calculator. The square root of 10 is irrational. But the square root of 81 equals 9. So it's not irrational because it's just 9. And 9 can be written as a ratio. Okay? Those are irrational numbers. Okay, operations. Operations are adding, subtracting, multiplying, dividing, exponents, like in order of operations. So is the sum of a rational and, because it's the sum of an irrational number, rational or irrational? What do you think? So if I add a rational number, let's say 1/2, to pi, what does that equal? Let's make 1/2 a decimal, 0.5, so we can add it to the decimal in pi, which is 3.14159, ... It goes on forever. The 5 is in the 10th place. The 1 is in the 10th place, so we're just going to add those, and we're going to get 6/10. So we will have 3.6, and then the rest of it, after the 5, there's just 0, 0, 0, so we would just add that to the 4.159, and all the decimals following. Is this number, 3.64159, ... on and on and on, rational or irrational? That's right, it's irrational. And that will be true for any sum, because if you're adding, let's go back to our algebra. If we're adding the fraction a over b plus some irrational number, we'll say q, you're going to get something that has q in it. Like, there's no way around that. So it's going to be irrational. Always. Okay? This next one is not going to be an always. So now we're talking about a product. A product means we're multiplying. So product of rational and irrational. Is it rational or irrational? So if we multiply, let's go back to, let's use pi again for an irrational number. And we'll multiply it times 5. 5 times pi. Well, you're going to get 5 pi. There's no way around it. The pi doesn't just go away and magically become rational. So this is irrational. But on our last page, we saw that 0 is rational. So what if we multiplied 0 times pi? What would we get? Well, anything times 0 is 0. And 0 is rational. So in this case, it depends. Okay, so the product of irrational and irrational, you have to be careful. If you're multiplying by 0, it'll be 0. There's another example that's going to be on the quiz, and so I want to cover it. What about irrational times irrational? Well, it's actually going to be sum. Irrational plus irrational. And then we also have an irrational, and we'll just abbreviate. Irrational times, we're going to use dot to show times instead of an x, because in algebra we use x for other things. So let's say that we have the square root of 2 plus the square root of 2. Well, that would equal 2 square roots of 2. And that is still irrational. But what if we had pi plus negative pi? What if you had 5 plus negative 5? Or 10 plus negative 10? They're opposites, and opposites cancel each other out. So in this case, pi plus negative pi equals 0. And if you remember, 0 is rational. So it could be both. Okay. An irrational times an irrational. To think about this one. I think this one is also either, because I'll give you an example of where it's irrational. So if we multiplied the square root of 2 times pi, we would just get square root of 2 times pi, which is still irrational. But if we multiplied the square root of 10 times itself, the square root of 10, and there's plenty of examples to show this, I'm just picking a couple. Well, that would equal the square root of 10 squared. And when you square a square root, we'll learn this later when we get into our exponents unit, but if you square a square root, they cancel each other. They're opposite operations, and it leaves you with just 10, which is rational. We know that. So in these cases, it could depend. These are all depends cases. So just kind of study that, and you'll be allowed to use your notes on the quiz.